System of equations. By definition, a system of equations is two functions. In this case, we're only going to look at linear functions that we're trying to figure out what ordered pair could I put into both functions that would make it true. Looking at a graph, I have my two linear functions. It's easy to find the solution to a system of linear equations when you're given the graph. Your solution is exactly where they intersect. So if you look, these two lines intersect at 4, -2. So 4, -2 is my solution. Look at this next one. What would the solution be? The two lines intersect at -4, -4. So C would be my solution. We need to read the problems carefully when we're looking at systems of equations because sometimes they want the ordered pair, but sometimes they just want one coordinate. In this problem, they're only looking for the y coordinate of the solution. So if we looked at the solution, which is -5, 6, which one is my y coordinate? 6. So my answer would be B. Why don't you try this one on your own? The solution is at 3, 2, and they're asking for the x coordinate, so that would be 3. You're also going to be asked to find the solution to a system of equation when you're given the equation. Typically, the first one will always be in y equals, or maybe not the first, but one of them will always be in y equals form. So that will be easy. The second one will not be in, so we need to transform this into y equals form by doing opposite of A over B, x plus C over B. I now have my two equations. So what I need to do is plot them into y1 and y2 and find the intersection. Let's go ahead and plug those into the calculator. So in y1 we have 3x minus 5, and in y2 we have -1 over 1x plus 7 over 1. The nice thing about our calculators is we can plug it in just like it looks. We don't have to simplify it. If you wanted to simplify it, you could, but you can also just leave it exactly like it is. So I graph those, and my graph is zoomed out. That's okay, we'll fix it for the next one. But I see my two lines, and I see the point where they intersect. That is my solution. So I can find that by using the second trace, 5 for intersection, hit enter 3 times until it says intersection, and my solution would be 3, 4. Let's try another one. Looking at this problem, my first one is already in y equals form, so that's going to go into y1. The second one is not in y equals form, so we need to write it in y equals form. So y equals the opposite of A over B, x plus C over B. That's going to go in y2. Graph it and find our intersection. I have the equations plugged into y1 and y2, 4 over 2x and 8 over 2. I would suggest that you pause it now and get these typed into your calculator so you can practice doing it also. Okay, we're going to have to, if you remember I was zoomed out last time, so I'm going to hit zoom 6 to make it a standard screen. I've got my first line that graphs. And the red line, as you see, goes directly on top of the blue line. We know from solving equations that when the two lines are directly on top of each other, it would be B all real numbers. Just as a quick review, what does a no solution or no real solution look like? The lines would be parallel. Alright, go ahead and hit pause, and why don't you try this one on your own. Okay, we know the first one's already in y equals form, so this goes in y1. In y2, we're going to do the opposite of a over b, x plus c over b. That goes in y2. Let's plug it into our calculator. Alright, we have it typed into our calculator. We graph it, and we're looking for our intersection. Our first line is in blue. The second line is in red. We see we have one intersection, so we find that by hitting second trace 5. We're calculating the intersection, and we see our intersection is at 2, 9. But we need to read the problem. It's asking for the y coordinate, so our y coordinate is A, 9. Let's try one more together. Go ahead and pause it, and you try this one on your own, and then we'll go over it. The first one is already in y equals form. The second one, we have to write it in y equals form, so y equals the opposite of a over b, x plus c over b. That goes in y2. We put it in our calculator. It's in our calculator, so we can go ahead and graph it. First line is in blue. Second line is in red. We can see that they intersect one time, so we find that intersection. Second trace 5, enter until it says intersection. And my solution is 1, negative 2. In this case, it is asking for the x coordinate, so my answer would be B.